Seen from the sky, water gives its blue color to our planet. But the fresh water that's indispensable to life represents an infinitesimal part of all that blue. Soon we'll be 8 billion people sharing this vital reserve that's gradually eroding due to pollution, waste, and global warming. 1 human being out of 3 already suffers from a lack of water. Perhaps the solution is to look under our feet, at the water in the dizzying depths of the earth, the aquifers. Over a period of 2 years, we followed Alain Gachet, a geophysicist and explorer who has perfected a revolutionary method for finding underground water anywhere in the world. This method has already saved hundreds of thousands of lives. It could save millions. This story begins in 2013. We meet Alain Gachet at his home in Tarascon in southeast France. Unknown to the broad public, his name primarily circulates amongst the humanitarian agencies of the United Nations. The offices of his small exploration company RTI are perched on the 3rd floor of the ancient convent where he lives with his family. When we arrive, Gachet is finalizing with his colleague a map of underground water resources of a totally unique type. UNESCO, the agency that's responsible for water management in the world, has commissioned him to explore the subsoil of northern Kenya. Today, East Africa is ravaged by the Great Drought which started in 2011. Alain Gachet concentrates his study on the most vast, poorest and most arid region of Kenya, Turkana. He christened his invention WATEX, short for water exploration. It's a mathematical algorithm that combines satellite images from NASA and Earth science parameters. We're lucky enough to discover WATEX's first image of the zone.
I had to carefully remove from the radio signal all surface obstacles that bothered me. So the mountains, volcanoes, cows, mosques, churches, everything was removed. Cars, villages, they don't interest me. What interests me now is the remaining humidity that will appear underground. It's very dark. If it's very black, that means it's very dry, immensely dry. There's no water down to probably the first 80 meters, but water might lay even deeper. That may be why it's so black. The water's gone down so deep that it disappears completely from the radar screen. And if by chance this black hole overlays the deep sedimentary basin where the water infiltrates deeply enough, we might discover deep water down to 1, 2, 3, 400 meters. But for us, that's interesting. We call that an aquifer. On this map, there is a giant aquifer there, with 2 little ones, 3 peripheral ones there.
And on this image, to make it more understandable, I revised the classification and introduced a color code that would be easily understandable, with the idea that there's such and such a probability to have water at such and such a depth, or when it's black there isn't any, etc.
I'm now confronted with a new underground galaxy, which is a new support which enables us to conceptualize and create a probability grid on the presence or absence of water up to a certain depth.
It took 6 months of assembly, analysis and computation for Alain Gachet and the geologist Delphine Sévestre to accomplish this mapping of the aquifer resources of Turkana. It's like an echography that sees hundreds of meters into the ground.
With the head in the stars, we see from space a new underground galaxy, which is practically unknown. Now, if we really want to concrete our ideas, we have to go on site and break rocks to check if we're not wrong.
To confirm the hypothesis of his map, he has to study the geology on site, so we follow him to Kenya. First stop is Lodwar, 48,000 inhabitants, capital of the region of Turkana, 11 hours by land from the capital, Nairobi. Gachet's research indicates the presence of an aquifer just 5 kilometers from the city of Lodwar. With his Watex map connected to his GPS, he looks for the spot where the water from the rainy season infiltrates the subsoil to feed the aquifer. He specifically looks for porous, permeable rocks, irrefutable geological proof that water infiltrates and does not remain on the surface.
There, big grains. That's what we call a recharge zone. The water is literally swallowed by the rock like a sponge. All the optimal conditions are met for this to be a magnificent aquifer. It's a considerable mass of sandstone that we see stretching out at a great distance. All of that is sandstone. All the sandstones are filling a great aquifer basin below.
Around us, arid land as far as the eye can see. Difficult to imagine a water reserve at 100 meters under our feet. And yet, the geological data collected by Gachet confirms the presence of an aquifer that no one had identified yet. Better still, his Watex map indicates the presence of an aquifer 20 times bigger at the very north of Turkana in the Lotikipi Plain. So we leave for the border in South Sudan and Uganda, heading on the track for Lokichogyo, 5 hours away. On the way, Alain Gachet detects a zone that might confirm the aquifer recharge pathway to the Lotikipi Plain. It's in fact a dried-out riverbed.
The transportation power of this river doesn't look impressive, but it is really strong. The sandstone grain size is relatively large. This can generate a pretty big aquifer on top quality downstream. So the water arrives from there and spreads out over the plain of Lotikipi, expanding over several thousand hectares.
On this Lotikipi Plain, the geological indications confirm the existence of a gigantic aquifer. But the ultimate, irrefutable proof comes when you drill. Alain Gachet hands his map over to his clients, UNESCO and the Kenyan government. The sites of boreholes and their depths are laid out to a precision of 1 meter. It's July 2013 and the drillers install their equipment. The first exploratory borehole is complicated to set up because there isn't just one but 3 aquifers on top of each other according to Gachet's hypothesis. The last aquifer must be hiding 400 meters underground, almost the depth of an oil deposit. This drilling is expensive, about $200,000. Alain Gachet must succeed. The stakes are very high. In this area, nomad populations with their herds seek scarce and intermittent watering holes. The drilling rig is visible for kilometers around, and the women flock to it, as if emerging from nowhere. What's being attempted here can change their lives. The technicians work in rotation day and night in the withering heat. On the 8th of July 2013, water spouts out.
This whole zone here, which today is totally deserted, and where the population continues to suffer from drought, malnutrition, and from undernourishment, I think we have the opportunity to transform this into a major economic zone.
This day marks a decisive step for Alain Gachet, who is deeply touched. The women thank him for having revealed the water that was always present under their feet. The aquifers are porous subterranean rocks that imprison the water they contain between 2 layers of impermeable clay. They're called confined aquifers. The reserves of water they contain are 30 times more important than all the fresh water on the surface of the Earth. Sometimes located kilometers down, the aquifers are not touched by pollution from human activity as the superficial groundwater tables might be. The water that feeds them comes from the rain and snow melt. It infiltrates the ground, sometimes hundreds of kilometers away, and slowly migrates through the geological layers.
An aquifer takes millions of years to fill up and only a few decades to be emptied. You can destroy an aquifer by pumping too fast without taking into account the rechargeable quantity. An aquifer that's dead is like a sponge that contracts one last time and won't fill up again.
Alain Gachet's expertise goes beyond finding aquifers. He also masters their functioning and knows if they're renewable or not in order to ensure sustainable exploitation. The 5 aquifers Gachet discovered in Turkana are renewable. This discovery is important, and in September 2013, on the occasion of a water summit organized in the capital, Nairobi, the Kenyan government and UNESCO announced the presence of 245 billion cubic meters of drinkable water in Turkana. The Minister of the Environment, Judy Wakungu, presents the WATEX map to the media.
We have now the possibility of actually having a breadbasket, in Turkana, something that we could never have imagined before. We have the possibility of having industries in Turkana. So it is very, very exciting news, and I think it's even going to take a long time for people in the country to even imagine. So I'm sure there'll be tourists who actually want to come and see the water in Turkana. It's very exciting.
The Professor Opio Akesh, a doctor of geochemistry, teaches in the geology department of the University of Nairobi. He's been designated by the Kenyan government to evaluate the WATEX system. He's already evoking the future.
We are only looking at the Turkana area, and from our results, we could see that this could be extended to other areas. And in fact, already other counties are looking into the possibility of using this system.
It's only after Dr. Gachet came up with this system that we are able to understand how the recharge system really operates.
All the experts confirm that the discovery changes things completely for Turkana. In his technical report, Alain Gachet posits that the great aquifer of the Lotikipi Plain multiplies 9-fold Kenya's freshwater reserves. The international press picks up the story. In Paris, Alexandre Tête, a researcher at the Foundation for Strategic Research, is well acquainted with this region of Kenya, but is skeptical about the benefits and value of Gachet's discovery for the inhabitants' development.
I remember an article of his I quoted in which he explains that thanks to water, the people of Turkana will pass from the Stone Age to modern times. That's also the way that many Kenyan developmental specialists and NGOs look at things, before arriving in a place they don't know and that they presume they're going to develop. All plans of the past which consisted of trying to settle the nomads around hydraulic equipment didn't work. Obviously, the discovery of water in Turkana is very good news. Now, though, who will take advantage of this? It's not the Turkana people who are going to invest in their own county.
And to be sure, it's thanks to the funds from the Japanese government that UNESCO and the Kenyan government launched the 5 exploratory boreholes in Turkana. The WATEX map of Turkana's subterranean water and all the data produced are now the property of the Kenyan state. It now becomes its job to transform these exploratory boreholes into sustainable production wells and to make its development choices with the local authorities. 2 years after the discovery of the aquifers, we return with Alain Gachet to see how this treasure of 245 million cubic meters of fresh water has changed the life of the Turkana population. It's 2015, and our twin-engine plane lands in Lodwar, the closest town to the small aquifer. Daniel Lochamin, who is very implicated in his region's development, plays the guide and interpreter. A few supplies and we take the road. Just at the edge of town, a happy surprise, wells have been installed by the Kenyan government. They're equipped with pumps and operate with solar energy. Alain Gachet notes that all the wells drilled according to his directions are productive. At last he can drink the water from the aquifer. He scrupulously takes note of the taste and characteristics. He also meets the population and asks questions about their daily uses for the water and how they are learning about agriculture and irrigation techniques.
We are very happy to have this water. Before the arrival of this water, it was very difficult. Now our animals can drink and graze here. Before, we had to walk with our animals to the river to find something to drink.
It was really hard here, very hard. For the animals, for us, even for our dogs. Everyone had to go to the river to drink. But thank God today we're truly happy.
Life has changed now that we can use this water. All the women you see here no longer have to walk to the river.
It makes me very happy because in 20 years, it'll take time. I think in 20 years, this will be California. They'll be able to produce all kinds of citrus fruits, all the fruits they want to provide some cash to these people here. They'll get richer. It's obvious this will require organization, but once the wells are dug and maintained, I'd say that here with good soil, everything will follow. The government really has to promote much more education, and particularly education in agricultural schools. Because agriculture, well, you can't improvise. The earth has its laws. You have to learn them. In Europe, we have almost 1,500 years apprenticeship now, 2,000 years, more. It takes a long time.
And also watermelon. Yes, we have seen. Watermelon, you have seen. Watermelon, it is how it seems coming up very good.
With water, you can make things grow here.
Yeah.
Sure. Yeah. It's not the best place, but the best place is what we're going to show you.
Yeah.
Gachet suggests that the head of the small agricultural community go with him to check on a spot that seems abnormally humid on his Watex map. After a half hour in the 4x4, off the mapped track, hidden behind a curtain of dunes, a carpet of wild vegetation appears.
Here is the land, the promised land.
We discover at the same time as the head of the community a gigantic green expanse in the middle of the desert.
I discovered by satellite south of Lodvar an extremely strange surface of some 1,400 hectares, entirely surrounded by dunes. When you cross the dunes, you plunge into a kind of basin with soil that's just begging to be cultivated.
There is some water.
Yes, it's moist.
Yeah.
It's moist. Yeah, of course you have water. If we drain properly the excess of water, you can start, with a little project. And you can grow vegetable all the year.
This region's entering a virtuous circle. They have the soil, they have the water, and now the oil companies are making discoveries. They have energy, access to energy. At last. That's the triangle of virtue. Energy, soil, water. It's the basis of prosperity.
2 years after the discovery of this first aquifer, we can see the beginning of development, but not prosperity. In the zone of Lodvar, the inhabitants crowd around 4 wells. That's a modest infrastructure when we know there's over 10 billion cubic meters of water here, enough to satisfy the consumption of a city like Paris for more than 10 years.
It's not 2 wells, 3 wells, 4 wells that these zones need. They need 100. For that, you need investment, because these wells are expensive. So I would say that for $3 million, we could already stabilize the resource.
We resume our road towards the north, heading for the giant aquifer of the Lotikipi Plain. For Gachet, it's a return he's been waiting for, to the first exploratory borehole where in 2013, women danced in the geyser of fresh water. Covering a surface of more than 4,000 square kilometers with reserves estimated at 200 billion cubic meters, the three superposed aquifers of Lotikipi possess a volume of water 20 times that of the Lodoire aquifer. No water, no women, nothing. The well's closed. There's just a sealed casing from the former well sticking out of the ground. Gachet checks that this tube, so complicated to install, penetrates the three aquifers, because he had only watched the drilling of the first. The three echoes confirm that. But then what happened? Gachet will ask the head of the Lotikipi district.
Water sample was taken to Nairobi chemist. When the community were asking why this water been drilled and it's not in use, so what we heard is that this water is very much salty, that it's not good for human consumption.
Because of these reports that water are saline, it's not fit for human consumption. But the question is, people have been drinking this water before. No reports are there that people have died.
Alain Gachet remembers that he had also tasted the water burbling from the borehole 2 years ago, and it wasn't salty. He's beginning to understand what must have happened, and he persuades the district head to accompany him to the closed well in order to explain.
It's a pity they don't produce water here. It cannot be salty. Free aquifers, you see? When they drilled, they mixed all the water.
When drilling, the driller ought to have isolated each aquifer with cement and make separate analyses. He didn't do that. As it turns out, the water in one of the three aquifers is saline. Gradually, the fresh water from the other two aquifers and the saline water mixed.
Lokichogyo is there, between the two mountains. So you have a corridor which opens to Uganda, and all the water swallows it's like the entrance of a bottle. And here is a big bottle. All the water comes into the big bottle with big veins like that. So this is a recharge. Every year, a lot of water is coming there. It doesn't come from the sky here.
As long as it rains in
Uganda, you have water here. You don't care, even if it doesn't rain here, you don't care. Water is coming from very far and then penetrates underground. Well, all the women dancing around, taking water from, and they drink the water with a lot of pleasure. And that's harming the people. Wow, what a story. Did they tell you how many kilometers they are walking to get water every day here?
They walk for the whole day, then come in the evening home. 20, coming back, 20, 40 kilometers
and
walking.
With all the cattle?
Yeah, with the cattle.
The height of absurdity. These women have 200 billion cubic meters of water under their feet. But where do they go now to get the water they need every day? Alain Gachet wants to note the GPS coordinates of the seasonal watering hole where these women go. Over the 20-kilometer route, we run into men and their herds who are converging from all over. Some have been walking for days.
They shouldn't have to depend on watering holes that are so unhealthy and polluted. Look, there you see the animals, all their excrement. They piss, they shit. I mean, the little girls drink that water, and they manage to survive. I don't know how, but The drama is that there's no well nearby. They could have made a well to extract water. And that's the difference between deep wells and these puddles that are conducive to malaria. The mortality is such that only the strongest survive.
In 2 months' time, get finished.
2 months' time it's finished?
Get finished.
Wow, so it will be dry very soon?
It will be dry very soon. 2 months, it will be finished.
And what will happen with all these people?
They may clash. I hope after this, maybe you will go up to the county headquarters and meet the governor.
We want a meeting with
and maybe explain to him some of these issues.
Gachet keeps his promise. He returns to Laudois, the county capital, to inform the governor about the situation.
We met 2 years ago in the plane from Oki Studios.
Yeah, we did. How are you?
Fine, thank you.
Welcome.
I made a special print before coming to meet with you in my office in France. I want you to have this document in hand. These are deep aquifers that are highly sustainable for centuries. If you drill for pastoralists, wells all along here, down to 100 meters, you will have fresh water all along here, no problem.
So once we've gotten a picture of this, then now we can plan to look for resources and maximize the usage of this water.
Alain understands that the governor of the Turkana region, who should be the most concerned, has never received the Watex map. Neither UNESCO nor the Nairobi central government had considered it necessary to supply him with it. And yet, with this information, his development objectives could at last become realistic. But what leeway does he really have? To be fully clear about this before returning to France, we obtain an appointment with Judy Wakungu, Kenya's Minister of the Environment, whom we had already interviewed in September 2013 when she presented the aquifer map to the press. Dr. Opio Akesh, who had validated the Watex method, accompanies us.
I think in terms of the work that we've done since we made the announcement in 2013, we have been drilling several boreholes for validation of results. We've had excellent results in Lodwar, and people have been using the water ever since. One borehole, I can't remember what the level was. I think it was 135.
No, there's a borehole that was drilled up to 320 meters.
320 meters.
And it struck 3 different levels of aquifers.
Yes.
But since this water was all mixed,
yes,
we do not know which of the aquifers was saline.
Yes.
So that one we have to rectify.
Exactly. Which means that at that particular depth, that water is saline or brackish. It informs us to now drill either in different locations or at different depths. So as far as I'm concerned, 2 years seems long, but it really isn't for validation. Sometimes if you compare, say, for example, with oil, you can announce the discovery of oil, but it takes 10, 12 years before you actually use the oil. We're making good progress.
The minister takes no responsibility and doesn't answer our questions precisely. In fact, few members of the Kenya government venture out into the remote region of Turkana, which they've abandoned to the NGOs. Nomads don't vote. After this second journey to Kenya, we realized that the discovery of gigantic reserves of water in a country that desperately needs it doesn't fundamentally alter the equation. Lack of political will, of the means, of a vision has a direct impact on the population. Today, approximately 40% of the Kenyan population lacks access to clean water. And around the world, some 5,000 children die every day from illnesses related to unhealthy water.
I went beyond my mandate as a scientist by going to see the governor and giving him the documents, and by reminding the governor of the importance of these subterranean objectives. I played my last card with this trip. I have no reason to go any further and to fight against windmills.
It's true that all work can sometimes be very, very politically engaged. And the decisions, of course, don't depend just on us. Sometimes it really makes you angry to see how your work can be reduced to nothing because of a country's politics.
In this long journey with Alain Gachet, we've seen how hard it is for him to be satisfied with just finding water. Everything about water interests him: science, economy, politics. Since childhood, he'd seen himself as an explorer in all of these spheres.
I saw it in Madagascar. I saw electricity arrive, the railroad. There was no magic, it was technology. And I said to myself, Alain, you have to be a scientist. You adore nature, be a botanist like your father. You could first of all be a geologist. But I told myself, no, first be a physicist, because everything is based on physics. This is the way to understand nature. I understood that quickly. And I would say that I had a ball with math and physics at the beginning, while remaining a geologist, prospecting for butterflies on one side and minerals on the other. The beauty of both of these facets. And naturally, I pursued my studies in higher mathematics in the best technical schools, and I'm still using my physicist skills. I went a long way in quantum mechanics and nuclear physics. In fact, my teachers wanted me to go to Saclay Atomic Research Center in France, specialized in nuclear physics. Up to the moment that I once again recovered my initial passion, geology, earth sciences, passion to decipher the subterranean world. There's incredible wealth down there.
With a master's in nuclear physics and quantum mechanics, he entered the Nancy School of Mining, which trains the best of French engineers. He learned about the management of energy and base metals. At 27, he was recruited by the French national oil company Elf Aquitaine. As an exploration geophysicist and geologist, he prospected for hydrocarbons in the North Sea. Elf awarded him the Innovation Prize for an invention allowing the discovery of dangerous gas-bearing zones that no one was able to see.
We're not just technicians, we're also protectors of the human community we bring along on our adventure. And this responsibility leads you at one point to meet and deal with powerful people, decision makers who have the power in their hands. Power can be dizzying, power to decide. For me, I had the technical power, but not the power to decide about investment in such and such an area, in such and such a country.
In 1992, he was promoted number 2 of ELF Congo in Congo-Brazzaville and entrusted with international negotiations. He met the new ambassador of the United States, William Ramsay, who was also a specialist in energy. Very quickly, the two men became friends. In fact, today, William Ramsay, who Alain Gachet calls his big brother, has become his neighbor in Tarascon.
So I think Alain was a fairly broad-gauge asset for ELF. My view of him has always been that he's a multidisciplinary assimilator. You know, he brings things from different disciplines, he brings theories, he brings practicalities.
In 1994, the president of Congo, Pascal Lissouba, decides to sell the shares owned by his country in ELF Congo. ELF's management in Paris takes advantage of the situation and sets a ridiculous purchase price. Alain Gachet refuses to conduct the negotiations on those terms.
But I said, you're screwing up the Congolese people. You're going to set off a ferocious civil war. You're pushing people to despair. They told me, Gachet, you're playing politics. Get out. Either you come back to Paris, or we'll send you to this low-level position in Pointe-Noire. I found myself really amputated, demoted. It's obvious that it wasn't acceptable, but I did what I had to prepare my exit for the future. And to prepare for the future, I'd say that taking into account changes in political relations between East and West, the collapse of the Berlin Wall, new technologies, the arrival of all the military techniques born from the Star Wars period, that trickled down to the civilian sector concerning observation from space, I saw that one day all of that will be useful for me. I'm an explorer. I remain an explorer. I knew that I wouldn't change my profession. I was going to leave ELF, but that I'd continue to explore the Earth in one way or another, but with different tools.
Alain Gachet left his comfortable situation with ELF. He negotiated 2 years of salary and was prohibited from working for competing oil companies during a period of 4 years. With his severance pay in pocket, he left for the United States to learn about the latest radar technologies. His goal, to set up his own exploration mining company.
I crystallized my vision concerning the use of radar in the rainforest with the pygmies, who taught me to find gold in some rivers and not others. Using radar, I quickly understood where the mother of gold was, and I created my firm in 1999. I have this vision that I'm going to do something brilliant. I have the tools. I don't know what I'm going to do, but I have my hands on an extraordinary tool that will enable me to come up with something brilliant. I didn't think at all of water, of course. I thought I'd get rich in gold mines, etc. When I saw the bunch of crooks that were there, not the first contracts, which were with people who were very, very serious, but when I saw all the others emerge from the bush with their treasure maps, boss, come work here with us, come do this, come do that. I've got diamonds here, I've got coltan there. There I found gold. Oh yeah, I quickly understood who these guys were. I saw mafiosi show up in my house in Provence.
In 2002, the no competition clause with ELF finally ended. Shell asks him to look for oil in Libya, and he accepts. It's while analyzing the radar images of Libya that his attention is drawn by an abnormal sign of humidity in the middle of the desert. His diagnostic is almost unbelievable: a gigantic subterranean water leak. The leak comes from the pipes feeding the great man-made river constructed by Colonel Gaddafi. Water is spreading over a territory as big as Portugal.
I told myself that experience is now going to let me discover aquifers. My ambition was to filter those radar images to such a point that the only thing that would appear would be humidity. I have to say, the idea took me over like a fever. I imagine Pasteur when he feels that with his vaccines. He's going to be able to save people from rabies. He gets mad. He's going to go all the way. He won't hesitate to sacrifice everything to achieve his goal.
From then on, radar exploration becomes Alain Gachet's core business. But how can you see underground with satellites that are in orbit 800 kilometers above the Earth? Satellites provide two kinds of images: optical images, which are color photographs close to the visual reality, and radar images, which are like black and white echographies that illustrate physical properties of the ground up to a few meters deep. An experiment with a simple lab radar shows how electromagnetic hyperfrequency waves react to humidity.
There you can clearly see that the more I moisten the sand, the more its radar response increases. The curve increases, and there it's quite evident.
I had Alain Gachet as a student. I think he remembers. We taught surface image analysis, and he came there because, as a geologist, probably having to do petroleum interpretation, he understood that there was a great deal of interesting information in these images. And then he happened to use the radar images, along with other data, in order to search for water at great depths. So that is his speciality, and he's an expert at it. The way he works, it's not a question of luck. His success shows that he has a real capacity for interpreting the landscape globally in order to know what's under the surface.
Radar is sensitive to two things: humidity and roughness. Roughness in this context means the rocks that are spreading over the desert that send back many echoes. But a surface that's totally flat yet humid will give the same signal.
For 2 years, Alain Gachet devotes himself to the elaboration of a mathematical algorithm to separate those two signals and to just keep the information related to humidity. In 2004, his invention hasn't yet been tested on site, but the humanitarian agencies of the United Nations hear about it. Among those agencies, the High Commission on Refugees is urgently looking for water. Hundreds of thousands of Sudanese civilians are fleeing the Darfur conflict to take refuge in Chad, the neighboring country. Marc-André Bunsley, working with the UNHCR, coordinates the technical aspects of water supplies in the refugee camps.
I wondered how we were going to find water for 20,000 people at a time, knowing that the refugee camps would be about that size. So that was kind of a panicky time at the HCR when we really wondered how we were going to manage to give drinking water to all those people and their animals. We begin by finding water supplies on the surface or water to be treated, and that's what we're going to distribute first. Trucking it in, we put it in the trucks to be distributed. It's extremely expensive, it's extremely inefficient, but it's usually the only source of water that we find right away, and then we begin to do some exploration, and we try to find other sources of water.
The first wells dug with traditional techniques are frequently unproductive. A waste of time, a waste of money, and the refugees continue to flood in. Marc-André Bunzli calls the UNOSAT, the agency affiliated with the United Nations that produces maps to guide the action of humanitarian workers.
Within our team, we have experts in just about every field. However, when we're asked about something so specialized, requiring multiple expertise, because at the same time you need expertise in, let's say, geology, techniques related to outer space, and knowledge also of the field, because these are, after all, territories that are a little special in the Sahara-Sahel zone. So there we needed to identify a geologist, a hydrogeologist who was perfectly acquainted with these different tools. It happens that I knew Alain Gachet personally, so we contacted him and set up this project together.
So the United Nations call me. They know that I have at my disposal tools that are extremely effective, and I'm the only one who's apparently available and open enough to innovation to be able to face this crisis with the right tools.
The clock is ticking. From his headquarters, Alain Gachet is searching for water for some 250,000 refugees. After 4 months of analysis and calculation, he at last discovers subterranean reserves and leaves for Chad, the country into which the refugees are flooding, to determine the drilling sites.
I discovered several groups of these refugees dying in the dust. It was total improvisation, in total disarray, and I even asked myself at one point, what are you doing in this mess, in this hellhole, in this universe that is totally falling apart? In order to continue my job, I preferred not seeing the refugees. So I locked myself in the car and did my navigating with no visibility. I'd say to the driver, right, left, straight ahead, stop. I'd go out with my hammer, I'd break a few rocks, verify the geology, and we'd set off again. We went through that process until we found a good place to install a well. I collected several blocks of rock in the car's trunk. With my pot of paint, I painted one in white and put it down there. I recorded in my mapping application the GPS coordinates, and I took off again to be able to indicate to the drillers who were coming behind us that that was the place to dig a hole. But when I saw the water gurgling forth in Darfur, it's not about oil, it's about people.
In 2005, his invention attracts the attention of some American scientists. In particular, Dr. Saud Amr of the United States Geological Survey. It's he who audited the WATEX method for the State Department. This international expert in radar remote sensing advises the White House on problems related to water.
I thought it is really good methodology and it worth trying it. And that's where we tried it in Darfur, and I was astonished with the success rate. And this is not something from us. The report came from UNESCO, UNICEF, and the NGOs. The success rate went to 98%. Every time they drill, they found water. To me, Alain is really a very good scientist. He is genius, actually. That's why I earlier said anyone can study remote sensing, anyone can study hydrology and hydrogeology, but it comes to the point, the expertise. How much expertise and how much talent you have. And there are a lot of gifted people in many disciplines. What happened here is the inferring.
From emergencies to the long term, at the request of the American State Department, the USGS and Alain Gachet study the resources in aquifers all over Darfur, some 200,000 square kilometers. In 2 years, results are impressive. 1,700 wells are dug to supply almost 3 million refugees. These wells are still productive. This success attracts the curiosity of the European Union, which invites Gachet to explain his methods.
Upon arrival in Brussels, from the very beginning, they say, Mr. Gachet, no, we can't give you 20 minutes, you have 5 minutes. In a little conference hall, a workshop. Why? What happened? Mr. Gachet, you're a dangerous man. You find water in war zones. I said, first of all, you asked me, the United Nations asked me to find water in war zones. And it's especially in war zones that you need to find water. People are uprooted. They're dying of thirst. Do you know what it means to die of thirst in your Brussels office? You don't know what that means. Me, I saw it. You have an obligation to help those people. And I'm a dangerous criminal because I find water in war zones? You're mad. And then the discussion on intellectual property took place afterwards with the Swiss aid unit and Mr. Banzli, who was running it, who was the advisor of the HCR. And when I refused to give my codes to Mr. Banzli, there was a complete blackout.
An interpretation of satellite images with, as a result, a quantification of water or a spatial distribution of resources that can't be patented. It's a scientific method that has to be open and has to be reproducible by others. If that's not the case, it's not science.
I invented something. It's the property of a private company. It's intellectual property. That has to be respected. It's protected by rules of secrecy, even if it's not patented. You want water? I'm going to bring you water. But the algorithm, that's my business. It's not yours.
And I just don't understand these guys that think that they're going to have that given to them on. Why? I'd like to know who they're talking about that shares scientific discoveries. We got people paid all over the world. You even have to sign off when you work in Shell or you work in a major company. You even have to sign off to say anything I develop scientifically belongs to this company because they're going to market that. They're going to make money on that. That's why they're there. Pharmaceutics, everybody. So to say that science is transparent and releases everything and makes it all available to everybody is absolute rubbish, and they know that.
When the representative of the HCR clearly tells me, Alan, give us your trick, because if you don't give it to us, you won't work with us anymore, I call that blackmail. It's unacceptable. That's the situation I'm reduced to with the United Nations. As for the Americans, I've made enormous progress with them in different geological applications I've developed. I've never had this problem with them. They never asked for intellectual property on Watex. They wanted water. I found them water. That's it.
While international organizations are financed by governments and private donors, Alain Gachet is a small businessman who receives no subsidy, with one employee and bills to pay. In spite of the success in Darfur, United Nations agencies will no longer call on him for several years. As for American scientists, they're only interested in the best method on the market, and that's Watex. The United States Geological Survey, mandated by the State Department, calls on Gachet's company several times to look for deep water. The house in Tarascon becomes Dr. Saoud Amer's second office.
We work very well together, and when he gets frustrated, I tell him, well, if you need to send the email to such and such, send it to me first. And most of the time, when he read it the next day, he changed the way he write it, so it has been working very well.
Alain Gachet is a character who can't be pigeonholed, who can fascinate as well as irritate. He destabilizes the formatted world of international civil servants, committing 100% to collective projects, all the while having no qualms about highlighting personal success. Saoud Amer and Alain Gachet have multiplied the discoveries of aquifers in arid zones like Ethiopia and Somalia. Collaboration between the two scientists has even allowed a refinement of the Watex method. After 5 years of purgatory, the United Nations once again called on Alain Gachet. His method's effectiveness finally proved more important than the criticism. 2 missions were simultaneously undertaken. The emergency mission to Kenya that we followed, and another mission of great importance, the identification of aquifers on a countrywide scale, Iraq. Conducted by UNESCO for the European Union, this Iraqi mission, very sensitive on the diplomatic level, is making slow progress. Alain Gachet meets up again with his partner Saoud Amer among the team of international experts. Iraq is a country divided between Arab and Kurdish communities, a country surrounded by hostile neighbors and ravaged by 30 years of war, a country in hydraulic stress where water is a major strategic concern. In 2015, the advance of the ISIL and the massive influx of refugees make the Iraqi mission, which was at a standstill, an absolute priority. Just after his return from Kenya, Alain Gachet organizes a meeting with the Italian and American experts commissioned by UNESCO.
So it's not we are trying to find water just for the refugees, but due to the diminished or the reduction in surface water in Iraq in general, due to many reasons, either infrastructure upstream of Iraq, climate change, population increase, agriculture, Iraq has to find other water resources to supplement the surface water.
The big problem of Iraq is that Iraq today is going to hit a wall, in the use of water, meaning that Iraq is being not able to meet the water needs they are going to have in the future, because Iraq depends on more than 80% of the water that enters from the upstream countries through the Euphrates and Tigris River. And Turkey and Iran, especially Turkey, they are building a lot of dams. They are regulating the Tigris and the Euphrates. So Iraq is the downstream country and depends on this, which is especially a political decision, a political management.
Water is a source of tension in the whole Middle East, and more particularly within Iraq.
The conflict between the Kurds from the mountains and the Arabs of the plains has been going on for thousands of years. One group has water and knows where it is. The other group also has water, but they don't know where it is. And the day we manage to find some, we hope that will calm things down. But it might, on the contrary, increase tensions. Because everything is so explosive there, we no longer have any idea of what things can lead to. So there are countries where, in fact, finding water in certain circumstances can be extremely dangerous. But I consider that it's always a good idea for a country to know where its natural resources are. Because when a period of peace arrives, maybe in a century, they'll at least know where they stand in order to get going again. If we cruise on an ocean of ignorance, we can't expect anything positive in the future.
The entire little team is working full throttle. Delphine Sevestre orders hundreds of satellite images from the space agencies. With optical and radar images covering 70 square kilometers, the geologist puts together a mosaic of the entire country, a colossal task. It's to this composite map that Gachet applies his algorithm. The first calculations isolate the signals of the underground humidity and permit to infer the presence of aquifers in Iraq heretofore unknown. On the eve of their departure, Saoud Amer prepares Gachet for the presentation of their method on a very delicate diplomatic terrain. For the adoptive American who had to leave Iraq during the dictatorship of Saddam Hussein, this is not a mission like any other. His superiors have prohibited him from setting foot on the ground. So we leave with the Italian hydrogeologists for Erbil, the capital of Iraqi Kurdistan. The UNESCO coordinator, the German Andreas Lück, explains to us the particularity of this mission.
UNESCO, by delivering this project to the Iraqi people on behalf of the European Union, the advanced survey of groundwater resources in Iraq, is the first of its kind. It's highly significant. It has never been done before to look into deep groundwater resources to the extent that UNESCO is doing it.
On site, Alain Gachet begins by inspecting an ancient network of tunnels that drain water towards the villages, the carrés.
These are dry stones. The water is very nice when you stop stirring up the clay. It's a water that's extremely pure, totally drinkable. The flow rate is weak but regular. Must be about 1 liter per second, which isn't ridiculous. A carrez is a hydraulic system rooted in a very ancient tradition going back 3,000 or 4,000 years, which is going to drain the water falling into this amphitheater. This permitted many small mountain communities to live in total autonomy, and this seriously displeased Saddam Hussein, who took it upon himself to destroy the carrez, to force the populations to flee these villages and go to the cities where it was much easier to control them.
We take the road again through the mountains of Iraqi Kurdistan. As in Kenya, Alain Gachet is looking for an aquifer recharge zone.
Under the river, there are several accesses to underground water. There's an environment that's probably very rich in deep water. The water can be exploited here without touching the river, with deeper reserves that must be considerable because the altitude of those anticlines that you see over there and are still covered with snow, well, when the snow melts, it's going to infiltrate this sandstone, which is porous and will permit the circulation of the underground water. And there, we are in aquifers that are renewable. It's a rock that's been chemically dissolved by the carbonic acid transported by the snow and has a very specific aspect. As if I had soaked this block in hydrochloric acid, for example. The water has worked on it, acidic water impacted it.
The geological survey of Alain Gachet confirms the presence of deep aquifers in this strategic zone where tensions are high. A zone where ISIL is expanding its domination and forcing onto the road more than 4 million refugees, according to the HCR. Camps are multiplying and the need for water is growing. Gachet notes the GPS coordinates of the new refugee camps, and his scientific reflexes lead him to evaluate the pertinence of the existing infrastructure.
Those are the camp's water reserves, so obviously it's a very strategic place, very protected. The water arrives from that hill up there, directed by pipeline. And apparently the reserves are enough to supply 11,000 refugees. There must be 2 or 3 wells there, but you'd have to go up on the hills to be sure. They must be pumping the water from pretty deep down. You'd have to discuss with the hydrogeologists. That's very good. Fine quality.
Even in Erbil, in the middle of the capital of Iraqi Kurdistan, a refugee camp has been set up. The governor has to manage the sharing of the resource between residents and refugees and try to avoid tensions.
The Kurdish people have reacted very well, because it's not just water, but also electricity, medical services, and education that these refugees, more and more numerous, require. We're not talking about 1 million, but 1,800,000 internally displaced and Syrian refugees. But the reaction of the Kurdish population has been very positive till now.
We always build refugee camps with the hope that people will be returning home quickly. Today, I know that when we develop a camp, we have to have the perspective of 40 years. So at the beginning, we build roads that are 40 meters wide. Like that, in 20 years, there may still be a road where 2 cars can pass. We're always in a kind of schizophrenic situation where we know that it's going to last a long time, but the host government opposes letting us do anything permanent.
Right, so it was a bomber we saw passing over.
Exactly, it was a jet fighter.
While we are visiting Iraqi Kurdistan, a counter-offensive of Kurdish fighters against ISIL is raging a few dozen kilometers from the 10,000 refugees in the camp of Kawagosk. Tension is increasing.
And when I say that the context is not easy, in Darfur I had my driver and 2 assistants who were assassinated. Not by the rebels, but by the refugees themselves, under the pretext that they were poisoning the water in their cisterns, simply because they put chlorine in to disinfect the tanks. And with no warning, no explanation, boom, boom, it's over. I like to create wealth because of that. Wealth is the only element that allows a conflict to be diffused. So my objective is not to find a little water, because a little water is war. With lots of water, we can begin imagining that we can build peace.
However, water has always been at the heart of conflict in the Middle East. It's difficult to imagine that it can contribute to peace in Iraq in such chaos.
The whole military strategy of ISIL in Iraq and in Syria aims at one thing: controlling the dams on the Tigris and the Euphrates. It began in February 2014 with the Fallujah Dam, for example, in Iraqi territory, where ISIL wanted to exert pressure on the security of the water supply downstream, but also by closing the sluices, provoking floods, and thus discontent among the population upstream. Holding the dams also permits giving electricity to people, thereby putting on your side certain populations who are perhaps reluctant to support this radical Islamist movement.
Control of the Mosul and Haditha dams is a key element in ISIL's strategy of conquest.
Iraqi authorities alerted me that if these two dams are destroyed, Iraq will practically no longer exist.
Summer 2015, back in Tarascon, the last stage of the WATEX operation begins. Alain Gachet processes the geological data collected in Iraqi Kurdistan. Saoud Amer studies the internal functionings of the aquifers. He determines the quantity and quality of the water, its age, and the speed with which it's recharged to ensure sustainable exploitation. He then models this information. While the computers churn through the latest data brought back from Iraq, there's a pause. In the courtyard, the temperature rises to 40 degrees Celsius. A scientist friend has nominated Alain Gachet for the Legion of Honor distinction. On the eve of the ceremony, Yves Coppens arrives from Paris to attribute the award. The presence of the paleontologist delights Alain. He's prepared a little homemade welcoming gift.
Here, whatever the climactic variations, there's always been water. For that matter, the radar signature is much lighter here. The image is lighter, which shows that here in these gorges, there's always been humidity, and people were distributed around the area.
Using his method, Alain Gachet found an aquifer in the region of Hadar in Ethiopia, just where Yves Coppens discovered our ancestor Lucy.
Your idea is absolutely brilliant. Your results fantastic. Your work immense. Seen through my eyes of a prehistorian, you make nomads become sedimentary through necessity. It's exactly, or almost exactly, what we prehistorians say through archaeology concerning the passage from the Paleolithic era to the Neolithic. In other words, the passage from an economy of predation to an economy of production. I name you, Mr. Gachet, a knight in the National Order of the Legion of Honor.
You don't struggle against nature, you struggle with nature. It's sort of like what Coppens says. It's not a question of trying to go back to the virtues of the past. Man has to adapt to the time that is coming. What's marvelous about technology is that it enables this adaptation to take place rapidly. If you have no past, you have no future. But seek to hang on desperately to the past while omitting possible immediate and future solutions for solid development, it's totally stupid. You know, it's interesting, but Teilhard de Chardin clearly saw that in the evolution of species, they always go from the simpler to the more complicated. We've never seen a species go back from the more complicated to the simpler. That was immediate extinction. Let's take advantage of our faculties of intelligence and adaptation to build the future.
The day after the party, back to the top floor. The printer is chattering. In exclusivity, Alain Gachet reveals to us the result of his work on Iraq.
This is the unpublished map. It's unique. All of Iraq has been watexed. And there we have a pure signature of water. Where does this water come from? It can't come from the Mesopotamian basin. It isn't connected to the streams and rivers that would arrive here. It doesn't rain here. It's really the Western Desert. Therefore, this water comes from down deep. There's probably a huge source of water that's asleep somewhere down there. The water comes from Saudi Arabia. It's going to gradually infiltrate the Mesopotamian basin and migrate 700 kilometers to arrive at the base of this fault, to here. And there it's pressure. There's practically 1 kilometer of head. There's so much pressure here that water is going to seep all along the length of the fault. And that's what we see on the radar image. That means that there are probably very large water reserves here under high pressure waiting for us. Here we are in a full-fledged cross-border process. So there is a real potential for the future, independent of the Tigris and Euphrates, independent of the policy of huge dams conducted by Turkey, which has full control of the Iraqi economy with surface water. With this, they'd be free of the Turkish dominance to rebuild a new Iraq according to a new paradigm.
UNESCO summons the whole team to a secret spot outside of Iraq. The hydrological advisor to the Iraqi Prime Minister and an expert from the Ministry of Agriculture and Natural Resources arrived from Baghdad. For UNESCO's project head, Andreas Luc, the result goes beyond what he hoped for. We get special authorization to film.
So we decline this project from space to ground, integrating all the package of georeference, accurate data, to be able to have a better understanding of the complex country which is Iraq.
Let's make this as the base map. This is the wetness map. That's where we think there is wetness signal.
Yeah. On the north of Jebel Sijra, up to the Syrian border, it's a beautiful, moist area. Means you have good soils and probably good aquifers below.
Yeah, it's a good aquifer.
Here.
And number 3 is there.
I have something here.
Choose one.
So, Mr. Sadek, now, the Iraqi army has to control this area.
The Iraqi army will
has to control that. Not in dirty hands.
This information then should be kept secret.
For the moment, yes.
For the moment.
As a result of this meeting, strategic objectives are defined. 5 boreholes over 1,000 meters in depth will be put in place. The next step, communication to the Iraqi government of the WATEX map, with the precise drilling sites on tablets connected to GPS.
The UNESCO official, Dr. Luc, suggests I publish. There are results that are exceptional, geological cross-sections that nobody has ever seen before. It's up to me to say yes or no, because when we put these publications out there, we'll have the Saudis, the Turks, and the Iranians all over us. So let's do our job all the way through, and when we've done everything we can, perhaps, if the political situation permits it, we'll publish. I don't know my fame to publications, but to my results. It's discovery that interests me.
After all these months of work, Alain Gachet, Saoud Amer, and the whole team grant themselves a moment of optimism. This incredible map, the product of a humanitarian emergency, is now the instrument for the rebuilding of an Iraq that would no longer be centered on the Tigris and Euphrates, an alternative to the saline groundwater polluted by war, but also a way to no longer depend on dams controlled by the Turks and by ISIL. In the foreseeable future, if political will and investments follow, this means that there will be water for everybody.
Just can you imagine a place with already with the water politics of Iraq and the neighboring countries and Turkey upstream and the rest of it, you start changing the dynamics of that by finding huge underground aquifers that can change the availability of water to everybody. You're shifting politics dramatically. And I don't know how, I don't know where, I don't know in what manner, what magnitude, but you're shifting things. Oh yeah, water's going to be everywhere in the 21st century. It's going to be on the climate change agenda. It's going to be on the resource management agenda. It's going to be on the political agenda. It's going to be everywhere. We'll see plenty of things about water. This would be, I would say, this would be the century of water.
I got into the Great Water War. I could say I waded into it up to my chin, up to my ears. I put my soul into it, but I'm going all the way.
Free and cross-disciplinary minds have always been the motors of progress. The great explorers drew maps of the seas and continents, but the depths of the Earth remain little known. No complete map of the planet's deep aquifers exists. Alain Gachet, with his algorithm and access to a supercomputer, would only take a few years of calculating to make that map. The discovery of water gives power to the one who controls it. But can we refuse a discovery under the pretext that we don't know what politicians will do with it? In about 2030, 1 person out of 2 will suffer from a lack of water. Science offers a chain of solutions that it would be wise not to neglect. With his invention, Alain Gachet is one link in this chain.
That's the risk. No, everything is okay. I want to taste the water.